So I'm just going to give a brief introduction into the UKRN and the Open Research Programme, which the open source hardware training is part of. So the UKRN is a consortium of higher education institutions which are coordinating efforts to promote reproducibility in research practices and research outputs. And the Open Research Programme is a 5-year programme within that, with the aim of providing the opportunity for institutions to uptake and embed open research practices. So this slide is just giving a summary of where we are currently with the Open Research Programme. It's got 24 higher education institutions who have joined the programme and 12 project partners who are working in adjacent areas and input into the ongoing work of the programme. So it's funded, it's funded over 6 years by Research England, and there's other funding from membership institutions and from the Scottish Council Funding Council. And it has 3 main objectives: to develop high quality training, to develop a framework of evaluation of open research practices, and sharing effective practices and promoting the alignment of incentives. And I just need to, at this point, thank Nicola from the UKRN, who very kindly provided the slides for this. So looking more at the institutional level, who are the people who support with provision for the Open Research Programme? So at each institution, there is an institutional lead who ensures that alignment with the Open Research Programme is accounted for at the institutional policy level. There's a local network lead who works at the grassroots level to ensure that staff members, students within the university feel supported to uptake these open research practices. And it's really about building a community there and ensuring that people feel represented. Some institutions also have open research coordinators. So for instance, I'm the open research coordinator for Southampton, to ensure that these 3 objectives that I listed on the previous slide are embedded in the institution. Now, one of the key outputs of the Open Research Programme is training. So for instance, my role at Southampton is really focused on ensuring that training in open research practices is being embedded and developed. So moving on to the open source hardware training that Andre is providing for the Open Research Programme, I'm just going to very quickly go over the course structure. Andre will go into some more detail later, but it's broadly over a period of just under 2 months, alternating mentor meetings and group sessions for people to develop an open source hardware project. Now, one thing I do want to draw people's attention to is there is a train the trainer session at the end of this course structure. Now, the training developed by the Open Research Programme is a train the trainer structure. And that means that what we are doing is we're providing training for individuals at institutions to go on and disseminate that training further in their institution, with the idea that we train up people to undertake these open research practices, and then they go on and disseminate that information about how to embed these open research practices in other individuals' research. They disseminate that further. So that is a very brief overview of the training programme within the Open Research Programme. I'll be around at the end to take any questions on that. It's just an introduction to provide some context to the wonderful work that Andre is doing. So I'll just stop sharing my screen and I'll hand over now. Thank you very much.
Thanks, Louise. So let me just share my screen. Thank you for everyone who contributed on the chat already about where they come from and what they would like to use hardware for. Let me just find, my screen. Hold on. I hope everybody can see this okay. Yeah, thanks, Dolly. So some years ago, we created this program, and I say we because, and I'm going to talk a little bit about this. This is a big community effort that was led by me and 2 other colleagues that are in different parts of the world, about how to share best practices on developing, or how to learn and implement best practices when developing open hardware, right? But before we talk about that, I thought about actually saying what is open hardware, because one of the things that I get the most is that this is kind of so new in the whole open research and open science space that people don't really know, right? And then I talk a little bit about why we created the program, what is it all about, who's it for, how it works in more details, and then the application processes, I guess, is going to be a little bit different than what I'm going to show you, because we're going to have to, couple this with the UKRN, and then we have a little bit of time, like Luis said in the end, for questions and answers, okay? At any time, if there is something that is not clear, feel free to interrupt me. Just unmute your mic or raise your hand, virtual hand, please. I rather answer questions as if they're pressing as they come, okay? About the program. So what is open hardware, right? And so there is a definition. There are a lot of very smart people working on the legal and the framework side of this, defining what is open hardware. I can share the link. I can share all of this, or we can share all of these slides later for people who are interested in the links. But roughly, the idea of open hardware is the following, right? All the information that is necessary, the bill of materials, the digital designs, the building instructions, what kind of skills I need to build a physical thing, are made freely available using certain licenses, right? And when I say a physical thing, on quotes, I mean really anything that is physical in the sense of it could be a chair, right? So you can have an open source chair, you can have an open source microscope, like we're going to see, you can have an open source art piece, and even things like molecules and enzymes and things like insulin. So there is a project online sharing all of the documentation you need to learn how to make insulin locally, right? Which is amazing. And of course, all of this, as I mentioned, is then released under specific licenses, very much like open source software is, that guide what is the fair and appropriate use. And then the definition, for instance, states what kind of files need to be shared, in what format, and what is the best way of sharing them, and so on, right? So some examples, right? So what I'm showing you here are two microscopes. The one on the left, it's a microscope from the 1920s, and the one on the right is a microscope it's a little bit more modern, right? As you can see, things changed a bit, but pretty much the technology in these microscopes didn't change. Of course, the optics are better. You now have cameras to digitize them, digitize the image. You can then analyze the image on the computer, but the technology is pretty much the same. So it's a couple of glass lenses that then allows us to magnify an image. And why do I put this here? Because one of the first things you'll notice, if you think about it, is that current microscopes that we can buy are great, but they're very niche in the sense of, if you're in Europe, it's easy to buy them. They're expensive, but it's easy, quote unquote, to buy them. So one of these microscopes that I'm showing you here would cost something like 5,000 to 10,000 pounds. They need to run on constant power supply from the grid, and they are designed for a very specific application, which is inside the lab with specific temperatures and specific air humidity and so on, right? And so now, if you're thinking about research, this is suboptimal because A, who's going to give this to students to learn and play around with if it costs 10,000 pounds? B, how many of these can you have in the lab? And so because they're expensive, it's hard to get multiple of them to do the research and the data collection that we need. D, as I mentioned, the suppliers are located mostly in the global north. And so even if you have the money and you are, let's say, in Brazil or in the Philippines, like someone here in the room is, I manage, it's really hard to procure them because then you have import costs, you have shipment costs, you have taxes on customs and so on, right? And so this delays research quite a bit, right? And the other thing is, who's going to want to tinker with this and customize it for new experiments, right? Because they're so expensive. And the other thing is, because you don't have the bill of materials and the plans, it's really hard to know how to customize them, right? And so they're great if you can get access to them, but the access to them is really limited and there are other shortcomings, right? The answer to this, quote, like in a rough way, is can we make tools and scientific equipment that are open source? So where, as I mentioned, we share all of the design plans or the biomaterials and so on. So what I'm showing you here are examples of 3 different microscopes. All of them fit on the palm of your hand. So you can carry them, you can put them in a backpack. They can all be powered by batteries. right? So they can run in places where, let's say, the grid is not super reliable, but more importantly, because they are connected via Wi-Fi to a computer, you can actually bring them to the field to do experiments. So here, in one stroke, what we're showing is that 3 different groups independently created 3 different types of microscopes and shared like all of the instructions that you needed to replicate them. And because they took a fresh look at how microscopes are built, they have a different approach to it, and therefore they can provide new and more exciting features than your traditional one, right? All of them cost under $250 to build. Of course, you need the time and the expertise to do it, right? But they are much, much more affordable. One of these examples is called the Open Flexure. And here I'm just showing you one of the publications, and all of these microscopes have been published in peer-reviewed journals. So they follow the scientific rigor and the scientific standard that everybody complies by. And here what I'm showing is that in 2016, they showed that this microscope that you can build for $250 can be used for malaria detection. So what you're seeing on the figure on the right is a blood smear under the microscope with an inset, with a zoomed version or with a magnified version of that image showing a red blood cell of a human with a malaria parasite inside. This is just to show you the places where Open Flexure has been built by members of this now global and thriving community worldwide. And so places like, the South Pole have people that actually have brought this to the South Pole to do research. And you can see that it's pretty much taken a lot of places, has been developed in a lot of, or has been built in a lot of places in the world. Right, so this is the kind of things that open sourcing hardware brings. Just to give you an idea in numbers of current trends in the space, this is a study that we're conducting right now where we are taking open hardware as a keyword from and using this as a search term in, let's say, PubMed, which is this example here. And in the y-axis, you're seeing the fraction of papers that have open hardware as a keyword in the search term in PubMed. And on the x-axis, you're seeing years. And of course, as a fraction of the papers, it's quite small because PubMed is not completely dedicated to open hardware, but it's rather interested in biomedical research. But what I want to draw your attention to is how rapidly this curve accelerates over time. So there are more and more people in academia designing open hardware and publishing papers describing open hardware. There are 2 journals, the Journal of Open Hardware and Hardware X, that are completely dedicated to open hardware designs. The CERN is one of the early proponents of open hardware. As you can imagine, the largest scientific experiment of all time of humanity requires their tool to be open hardware, because you can imagine that if a company goes out of business and a detector that is inside the Large Hadron Collider fails, they need to have the blueprints to be able to replicate it if a company that provided to them is not present anymore, right? So there is a lot of investment from a lot of different scientific areas into open hardware. Sorry, I know it's quite a lot of information, but I wanted to get a check-in. Is everybody so far so good? Are there any pressing questions? Because I'm going to start talking about the program itself and why we developed in a bit, but I thought this was a good overview before diving into the Open Hardware Makers program. Is that all right so far? Yeah, okay. Well, if there are any questions, by all means, just let me know. And so why have we created this? Like, now we change gears completely, right? Like, now I'm going to talk about the Open Hardware Makers program and why we created. Sorry, Jeremy, you have a question?
Thanks, Andre.
Yeah.
We actually built the Open Flexure here in the Philippines. So that was one of my research projects. And we know Richard Bowman and his team because of that.
Yeah.
A question, maybe this for later, but what's the concept on sustainability for open hardware? Our experience is once we built it, a lot of other labs, so some academics would really like to build it, but others basically just want to actually do their research. So
Yeah.
that's something I've been reflecting on. You know, how do you actually sustain these activities after you've actually built the thing?
Yeah. So there is so it's a very recent field, right? You can imagine. And so there are companies now that are appearing that are selling open hardware, right? And so in the terms of sustainability, then as a company selling hardware, you as a researcher, you don't have to build it anymore. You just can buy it, right? And because you can see as a researcher, you can see the entire bill of materials, you can know if the company is charging you, maybe 100 times what the bill of material is, or just 10 times or 2 times. And so you can make yourself the decision, do I want to buy it from them or do I want to invest the time to build it myself? Does that make sense?
Sure. Yeah. I think that was what I was thinking. But maybe that's a conversation, Andre. Like
Yeah.
I've been reflecting on kind of the other half, like the sustainability and business models that would help support open science, just
Yeah.
based on my experience. But I'm
Yeah,
happy to discuss
definitely.
that on another
So
forum.
very active field of discussion. Definitely can share some links and things, and happy to chat about this later as well. Yeah. Great. Thank you. Are there any other? So please raise your hands if you have other questions. But if not, in the meantime, why did we create this program, right? Like, why did we create a program that trained people into learning the best practices of open hardware? And some of the reasons are listed here. So for instance, I have built it, but no one knows about it. So as a developer, I can build a piece of hardware, but if nobody knows about it, it's not that it's useless, but it misses the purpose of being a community resource, right? Um, or somebody says, oh, it's open, but I don't want to make it commercial in any way, right? And so this is also fair, and there are ways of doing this, and this is something that we can, like help people and support them and navigate through this, right? Or like a very common one also for open software is like, I have built this, there is a community, but now I have, you know, many questions now on the forums and the repositories where I share this, and now the only thing I do is to reply like these things, but I don't see an income, so I cannot properly sustain this. So it's not sustainable, right? So there are ways that we share in the project, like how can we make this sustainable without burning out, right? Or I want to contribute, but I don't know how. Oh, then you as a developer, if you have people that might be wanting to contribute, then you might have ways of like letting people contribute. So the point is, the whole training program is a way to make your project on open hardware sustainable, in the sense of like, how can you foster a community where everyone respects each other, that doesn't lead to burnout? How can you make sure that your hardware is not going to become a burden to you? How are you going to make sure that this actually gets the word out and people will start using it, right? And how do you avoid duplicated effort? So one you can see here is like, yay, we're making yet another air quality monitor from scratch, which is very common in this space. People want to be the new thing, and so they start something new. And so one of the first things in the program is like, do the research, like what is available out there, how can we join efforts with others instead of starting something new from scratch, right? And so, oh, sorry, it seems that something, I'm just going to stop sharing for a minute and then start again, because it seems that I had a little bit of a problem with my sharing. Hold on, sorry about this. Here, yeah. Okay, so then how do we tackle these things, right? And this is why we created Open Hardware Maker. So the response to all of those whys is a mentorship program sharing best practices in open hardware. Who's it for? So this is basically for anybody who has an idea, a new idea, or an ongoing project. It can be one person, it could be a team of people, it can be any domain really. So you can have like an educational piece of hardware, it can be a scientific equipment, it can be something for social innovation. It can be a business idea, right? It doesn't matter. It doesn't matter which background you have. This is really tailored to anybody who wants to learn the best practices in open hardware. And it's for people who are willing to learn and apply what they're learning to their projects. And you can be, initially Open Hardware Makers was done to be distributed like for anybody around the world. And people who have been going through the training really have come from all around the world. But I suppose that this new edition with the UKRN, I think initially is more tailored to people in academia in the UK. But I guess Dolly and Louise, we can all answer this in more detail later, depending on the appetite from the people who are in the webinar. So how does it work? As Luis briefly mentioned, it's an online training program where there is a whole curriculum. There are 8 weeks worth of content, with the first and the last week being self-reflected, and so you do it on your own time. And then it alternates. So week 1, you're going to have a community call where you're going to show people what you did in the previous week, and then also share with, like, learn from others how they've approached it, what kind of problems they've encountered. And so we're trying to foster communities of people that are going through the same problems and can help and support each other. And then the week after that, you have a mentor call where a mentor then helps you, guide you through, oh, I'm facing this problem. And then the mentor is going to suggest to you things that you could look into, people you could contact, how you could approach things. They're not there to do things for you, but rather like to give you pointers and indicate where maybe you should look into things. During the project, there is also an expert assessment. So I think close to week 6 or 7, there is a moment where we call in experts in the field that they're going to look at your documentation, they're going to look at your project, and they're going to make suggestions. Oh, this is great, but have you thought about this? This is awesome, but can you look at it in this way? Or maybe look, these files need to be revised because right now it's impossible to replicate them, and so on, right? And then by the final week, or now before the final week, because now the last week is train the trainers training, right? The final week is a public demo where we do an online call that is open to everyone in the program and everyone in the world, where people have the opportunity to pitch, like to do a little video on their project that then can later be used as, you know, an advertisement for their project. And this is what we call a public project demo, right? And so our intention is that with these regular meetings and expert assessment and public demo, the very least that everybody comes out with is a publicly available documentation in different stages, because if you just started with an idea, there is only so much you can do in these 8 weeks. And if you have already a full going project, there is also only so much you can do in these 8 weeks. But there'll be, you know, a little video and somebody who have reviewed your documentation. And so definitely will have brought your project at least, the very least, one step closer to being fully open, right? The curriculum itself is not something that we created out of the blue and just by ourselves. And so initially, me, Julieta Arancio, and Alexander Kuchera have developed this curriculum. And with some funding from the Mozilla Foundation years ago, we put this through a community scrutiny process where we invited many people from the open hardware community to revise the curriculum. And so I think there are over 30 or 40 people that made comments on the document of the curriculum and suggested improvements. And so we applied all of those and made everything freely available online. So even if you wanted to do this self-paced, the curriculum is freely available and you can do it. You just won't have the perks of having the community calls and the mentor consultation and so on. But the point is that this is not something that 3 people developed themselves. There was a whole push from a whole community of people that then made suggestions. Of course, the curriculum is still open for more suggestions. So if you have points and doubts and questions, by all means, feel free to reach out to improve this further. And so I mentioned this already, right? Sorry, I know it's a lot of information, but I hope this is clear so far, right? So the content of the curriculum is that we have 7 content modules with submodules. Sorry, this is not 2 weeks for each module, but rather 1 week for each module. And each submodule has the same structure, right? So this is what it looks like. So this is module 2 in submodule 2.2, right? And so one of the first things we approach is like, do you need to create what you're thinking about creating, or is there an existing project already there, right? And so we talk about not reinventing the wheel. So there is a little bit of content on the curriculum that tells you a little bit with links and things. Then there are assignments for people to do and more resources that you can check to go deeper into that topic, right? So it's basically really short kind of lessons with content, assignments, and resources. Then, as I mentioned, there are mentor meetings every 2 weeks, right? And so you have the opportunity to review the progress on the curriculum, discuss problems and opportunities, and receive one-to-one support from a trained mentor. and then you can access resources and contact experts. So your mentor should be able to point you in the direction of experts. So let's give one example, right? Oh, I'm developing this microscope, but I'm having trouble with the optics, right? Like your mentor, either they know somebody or they would contact us, the organizers, to then find someone who's a specialist in optics to be able to, like, if they have time, provide you a little bit of guidance on where to look at for information and where to find solutions. Then there are the cohort meetings. And so you do peer review of the work, you interact with other mentees, and you have a Q&A with invited speakers. So we have somebody that comes to talk about a certain topic, which is their specialty that is related to the program, that then will give you more insight from an expert point of view on that specific topic. As I mentioned, on week 6, there is an expert review. And so each project is going to be assigned to an expert who's going to do the review of that project. And that is dedicated to that week 6, because then you kind of make a beta of your documentation and you send it out as a package to the expert that you've been assigned to, and they make a review of that, a snapshot, if you will. Right? But during the entire program, we're happy to put you in contact with experts from different domains. And so if you have a question, as I mentioned, we can simply link you with that expert, right? So it could be technical, financial, legal, community, whatever it is. In the end, there is a public call and a global sprint, right? And the goal is to present a demo at the public call. And so in preparation, we organize a weekend global sprint, optional for the mentors, before the call, where we have a Zoom room open most of the weekend, and then people can join and, ask questions and so on, and get support in preparing their demo for the public call. This is all live streamed, as I mentioned. It takes place on week 8. So the commitment that we ask for people that are joining the program is about 3 hours a week for 8 weeks, but this is asynchronous, right? So you can dedicate maybe like half an hour every day for the entire week, and this would account for your 3 hours mostly. And so it's 1 meeting per week and then 2 hours to work on the curriculum per week, right? If you work on the assignments, what we ask is that people work on the assignments on a weekly basis. So this makes small and nice increments without seeming to be a gigantic monster to be tackled, right? And if you attend all the scheduled meetings and communicate early if you can, that makes sure that we can prepare on the opposite side and make sure that everybody's following in the right pace and so on. And then, of course, the only thing that we ask is that people are responsive to the communications from mentors and the organizers. So the application process is a little motivation letter about, like, we gather info about you, about the project, and a little motivation letter on why you'd like to apply, just that we understand better, like, what it is that you're trying to achieve, so that we can match you with the proper mentor and the proper experts and everything. This needs to be updated for this coming call. But I will do this in the next couple of days and so on, and then this will be free, like, will be available soon for people to apply. Right, and so we are gonna then review the applications. Luis, do you have a question? Or do you want to make a point?
Quickly, also, if people are you talking about joining the UKRN training or more widely the open source hardware as a whole?
Mm-hmm.
Is it via the UKRN training you're talking about?
Yeah, I mean, this is what we did previously on the thing, and we need to adapt this for the UKRN, right? And this is something that maybe, sorry, I should have considered before making the presentation, but the whole point is, yes, for the coming cohort, this is all coupled with the UKRN, so we need to streamline this, right?
Cool.
Yeah, and so the whole goal here is to make sure that whoever applies prepared for the program, right? And what is the level of openness of each project and how we can better support them into making this one more step, or hopefully one more many steps towards being more open and state of the art, if you will, open hardware. Of course, we can always try to offer support. And so in the past, and of course, this is open to whatever this new cohort is going to need. But in the past, because we have people applying from regions where, let's say, connectivity was not great, we offered support with buying data packages for connecting to the calls, right? We offered support in people that were that needed to have childcare while they attended the calls and while they worked on the projects. And so the whole point here is that we're quite open to trying to find ways to support you so that you can properly attend the call and the program in the most optimal way. Yeah, so this is pretty much all I had to say, and I'm sorry that was a lot of information in very little time, but I'm happy to take as many questions as people have. Yeah. Were people seeing my slides so far? Okay, good. Thank you, Derek. Yeah, Ho, do you have a question?
Yeah.
Mm-hmm.
In the earlier part of your beginning or part of your presentations, you art is mentioned as hardware. I'm a bit confused in terms of two areas in
Yeah.
relation to your presentations. One is, first of all, art is non-reproducible and very strange to create an open hardware to describe how a piece of art to be made by another person in another part of the world. But it's a good idea, I suppose, so that expensive masterpiece, Van Gogh, can be reproduced in other part of the world. So I'm a bit confused about art rather than science that emphasize science and engineering emphasize reproducibility, which I do understand as a scientist, but as an artist, I find there's a contradiction there in the nature of artwork itself. The first part. Second part is in relation to your examples. You mentioned about very exciting physical hardware can be reproduced in different parts of the world in terms of practicality and feasibility. However, the example you give so far, it seemed to me not really the hardware able to virtually reproduce everywhere for those who learn, but it is more the documentation of know-how, which is about knowledge itself. To me, psychologically speaking, it is more store of knowledge-based, knowledge-intensive software. The gray matter software is not really physical hardware. The example you mentioned about the microscope, it is about the documentation of know-how, the knowledge of how to make the microscope, but not really a physical microscope as such. So I'm a bit confused there.
Yeah. So to answer your, these are excellent points. To answer your first one, right? So the art point was that, I mean, of course, it's impossible to share the documentation on how to replicate the Mona Lisa, right? You can share, what was the canvas, what was the type of paint, what kind of brushes were used, and so on. But at the same time, there are artists that are working with digital media and are working with other types of hardware. So one example very close to us, right? So here in the department, there is a collaboration between an artist that works with visual installations and researchers in neurosciences, right? And so I help them make their art installation interactive, where this artist has, what do you call them? They come to a gallery and they put projectors where they display images that are based on the research of the scientists here in neurosciences, right? And it's interactive because people get to wear the smart watches as they walk in the gallery, and this whole thing measures their steps. And as they reach a certain number of steps, the art installation changes, right? What is projected changes. And so we can make all of this package kind of open source so that other people can replicate this you can replicate the same art installation in multiple places at the same time. Think about flat packing IKEA kind of things, right? And then more people can experience this at the same time everywhere. Of course, then this depends on your definition of what art is, right? But the point is, of course, certain things you cannot replicate, but other things you can, and this is what I'm alluding to, right? So even if you're making a sculpture with a CNC machine, right, you can then share this and so on. I hope this answers your question, right? And then the second one, which is, again, you're absolutely right. Like, unfortunately, because we don't have teletransporters, it's impossible to share over the internet the actual physical hardware, right? What we share is the know-how, the documentation, and the blueprints on how to do it, right? But because, for instance, you can buy a 3D printer from AliExpress for 200 pounds nowadays, in principle, you can also, I mean, of course, price and cost and how affordable it is going to change from country to country. But the example of OpenFlexure, right? It has been built in several places across the world where it's inaccessible to have a traditional microscope. And just by sharing know-how, people can then find the tools and buy the tools they need to build the actual instruments, right? So you're absolutely right. We're not claiming that we share the hardware itself, but it's rather the documentation of the hardware and the know-how on how to build the hardware. Yeah?
Thank you. Yes, you have answered my questions.
Thank you. Derek?
Sorry, I couldn't resist jumping in on the art problem. I mean, that was my that was my previous experience in artistic practice. So, I mean, first of all, there's artistic tools. So artists are tool users, as tool creators. So I think these are good territory for open hardware, just as open source software has been useful to artistic communities, so can hardware. There's also artist series, so there's serial object. So there are artists that work in sort of generative hardware territories where working to produce, say, a small synthesizer that might be purchased but have a different kind of set of qualities that come out of it. So I totally get the idea that the example of open hardware and an art practice. And of course, Linux in the software area won an art award, as an artifact. So it was really just to sort of jump in on that kind of line of questioning.
Thank you. Yeah, I mean, perfect. I don't have anything to add. Do people
take my
Sorry.
hand down? That's right.
Louise?
It was just to kind of quickly go over the application process for people who are part of the UKRN ORP. Is it just okay if I do that for a couple of minutes?
Yeah.
Perfect, thank you. So for people who are part of the UKRN's ORP, if they're working institutions that are ORP members, then you can apply via your institution's Open Research Coordinator for the open source hardware, and then there's the additional step of applying for the through the open source hardware website, isn't there, Andre?
Sorry, say that again, Louise. I was reading the things on the chat because there are some interesting
Don't worry.
points here.
Yes, so I'm just saying that for people who are attending who want to do the open source hardware training, who are working at open research program institutions, then they would need to apply via their institution's Open Research Coordinator to attend the open source hardware training. That's all fine?
Yeah, I think that's fine. I mean, this is, off the cuff here, right? And we need to discuss if this is really allowed and possible. But if there are people who are not part of the UKRN network yet, if they could at least express interest via email, and then we could work out how that could be, like how they could also join depending on the numbers of people and so on.
So yes,
does that make sense?
Yeah, so that I think if we meet at some point and have a discussion around that.
Yeah. Okay. Yeah, so I guess the take-home message for people who are not part of UKRN but are interested, please do send us an email so that we know that you exist, right? And then we can make sure we come up with something that might work either for this cohort or for the next one. Does that sound good? Okay, great. There's a thumbs up on the screen, so I think Luis is happy. Are there any other questions or any other comments? Well, I hope this was then clear. Yeah, sorry, go ahead.
I'm sorry, I've got a really quick one. For people who are developing open source hardware and they want to join the wider network, but not necessarily do training as such, can they join the network?
Yeah, so there are excellent forums online on open hardware. Let me just fish the link and I can send it here. There is also a question about previous projects in the program, and I can share that as well on the chat, the question. Just give me a moment, please. Here. So on the link is a link to the GOSH forum, and GOSH is the Gathering for Open Science Hardware. It's a pretty big community of people from all around the world, and they're not only academics, but artists, or sorry, they're not only hardcore scientists, but artists and community people that are working with community science, not only academics and so on. And there are many, many interesting projects and discussions there, really worth a look. And for previous projects, let me just send this out, this other link. Here we had, yeah. And so the projects really that we had are really from a varied background, but what is there doesn't mean that this is all the types of projects we take, right? It's really about what you have as an idea for open hardware. We're really happy to, welcome you into the community and so on. The other thing that I think is very important, even if you just have an idea that you like to start developing, that's also for you. Right, so you don't need to have an existing already running project, because the sooner you start learning the best practices, the better anyways, right? As I said, in the end, the only commitment or one of the only commitments we have from people is that they share what they've been building and documenting and so on. So online with others from the get-go, right? So either you already have something that it's open that you're gonna then refine, or you have an idea of something that you want to make open. And so the requisite is that then you make this idea, and even if it's just, like a paragraph or something, available online, and then work from there during the program. I hope that makes sense. Okay. Are there any other questions?
Not really a question. I mean, if you're drawing to an end, I'd like to thank you and say that the work we're doing in the immersive area, I think we've got a community that would like to participate in some way. Just need to talk to them and the crossovers we have with the scientific community. Firstly, it's very much a sort of art science straddling thing. So so I think the project is pointing towards only the scientific community, or is it open to sort of artists who are engaged in sort of science practices?
We welcome everyone. I mean, before we had more of a science focus, but I think this is limiting ourselves, right? And limiting the conversations that we can have.
Okay, that's great. I'll definitely be in touch.
Okay, cool. Thank you.
I want to say thank you to Andre, because this is just, your work is so amazing.
Come on, thank you.
Thank you so much to Andre and Louise. Just one last call if anyone has any more questions. But if not, perhaps we can finish a bit early and have a little break. I don't see any hands up. So yeah, thank you so much to our speakers. I will send around the edited recording of this meeting within the next 2 weeks. And with Andre and Louise's permission, I'll also share the slides as well from today. And yeah, I will compile any links from the chat and send those in that same email as well, just so people can stay connected with anything that was shared today. But thank you very much. Oh, we've got one question just from Jeremy. Do we email for application details? Is that to email you, Andre? Is that correct?
No, I would say maybe
Okay.
let's focus all emails on the UKRN admin, if that's okay.
Okay.
Because then we don't lose track of what's going where, if that's fine.
Right. Okay. No worries. So yeah, if you send those emails, I pasted it. Just paste that inbox again. Thank you, everyone. Take
Thank
care.
you.
Thank you.
Bye. Bye.
Bye-bye.
Bye.